Bismillahirrahmanirrahim. Dear viewers, welcome back to the Commercial Building Design course in ProtaStructure 2021. In last part, we have finished modeling of this commercial building. In this part, we will do analysis and design of beam and columns. In the next part, we will go for flat slab design and then we will go for foundation design. At last, we will go for detailing. After finishing the building model, we have to go to the analysis tab, then go to building analysis. From here, we can check our project parameters. We will use ACI 31814 code. From here, we can choose our code according to our region. Loading code, we will use AC 710 code. Wind load, we will choose AC 7 2010, and earthquake load we will choose UBC 1997. From here we can check our foundation settings. We can provide here allowable bearing capacity of soil, here by default 200. According to soil report we have to provide this value. Lateral drift settings, here we can provide the project header. Now we can go for material properties. We will choose concrete properties 30 MPa, apply to all members. OK. Main river we will go for 400 MPa. From here we can change the strength or we can add new customized material properties. We will go with this 400 MPa, apply to all the river materials. Link will be same, and here we can choose our river diameters for main bars. I will choose diameter 14, 16, 18, 20, 22, 25. Maximum I will go for 25 mm dia river. Apply to all members of this river class. OK. And for link we will choose 10 mm diameter, 12 mm diameter. Click on OK. Now click on OK. Now we will go for seismic parameters. Here seismic zone, this data according to the seismic zone map of our country. Here I am going to use seismic zone 2A, seismic zone factor 0.15. Click on OK. Seismic source type, from here we can choose our source type. Magnitude more than 7, magnitude in between 6.5 to 7, and magnitude less than 6.5. I will go for type C. Click on OK. Structural parameters, occupancy category, I will choose standard occupancy 1. Seismic importance factor 1. Click on OK. System category, we will go with dual system, because a dual system is a structural system in which an essential complete frame provides support for gravity loads and resistance to lateral loads is provided by a specially detailed moment resisting frame and shear walls or braced frames. We have shear wall and moment resisting frame system, so we will choose dual system. Click on OK. Then structural system, concrete shear wall with SMRF, this concrete shear walls with steel OMRF, These are different types. For choosing response modification coefficient R, we will go with R 8.5. Click on OK. Direction 2 also same, dual system, and D1. Click on OK. Soil parameters, this will be chosen according to the soil report. I will choose this one, very dense soil and soft rock. Click on OK. Spectrum points, this will be automatic. Analysis, apply accidental eccentricity 5% and number of vibration modes to consider. Here it is 6. We can increase this number according to the floor number and degrees of freedom in each floor. I am keeping same as this is to save our time for analysis. If we increase this number, the accuracy will be increased. Now go to structural irregularities. If there is any structural irregularities in plan, accordingly we can choose this option. Settings, post analysis checks. Here it will check all the things is required for the analysis of a building structure. So click on OK. Now we will go for loading combinations. If we want to apply P delta analysis, we can click on this and go to loading generator. If we want to go for construction stage analysis, we can click on this. Go to horizontal load combinations. Here seismic loadings. Go for wind loading according to ASC 710. We can use cracked sections for wind load cases also. Now click on OK. So accordingly the load combinations generated on OK. Then go for wind loading. It will automatically generate the wind loads. Wind load calculator. Here we just need to define risk category. Then we need to define the wind speed meter per second. For example, I am going with 30 meter per second. Wind directionality factor, this one, here it is given the table. Accordingly we can choose the factor. Close this one. Terrain and surroundings, this will depend on the geographic location of the project. Click on apply. OK. Then we will go for model option. Here material and section effective stiffness factors. According to the code recommendation, stiffness will be reduced to the recommended values to consider as cracked section. Click on OK. For other settings, I will click on default settings. Shear wall model, I will go for finite elements shell model. Shell width 500 by 500 millimeter. Slab model, slab to define rigid diaphragm. All stories, include slabs in the building and stories to be meshed. Here I am going from 2 to floor level 10. Include column sections FE model. Click on this. And shell element size, we can use default 1 meter by 1 meter, or we can reduce it to 500 by 500 millimeter. I am keeping same as it is to reduce our analysis time. Then we can choose other settings from here. Now we will go to analysis. First we will check our model if there is any warning or error available or not. Start. Building model check completed. Number of errors 0. So close this one. Now we will go for building analysis. Here, if we want to display analytical model after finishing the analysis, we can keep this turn on. Otherwise, we can turn off this one. After finishing the analysis, we can manually see the analytical model. Now go to building analysis. It is better to go for analysis first. After finishing the analysis, it will give analysis summary report where we can see the serviceability checks. Click on OK, close. Now we can go for analysis result review. Post analysis, display analytical model. We have meshed history 2, 4, 6, 8 and 10. That's why it is showing this floors in the analytical model. Here we can see the displacement for different load cases or load combinations. For example, EX, WX. We can see diagram. Now we can see counter maps for the shells and walls. We can see the deformation along X axis, Y axis, Z axis. We can see plan view. We can check settings. Edges, we can unmark this one. It will show like this. We can filter stories. We can remove shell from the view or slab from the view. Here we can see the axial load. In the analysis, if we choose non-factored dead load and live load result, then here DL plus LL load combination will come to show our reaction load. So in this way we can review our result. We can close this tab. We can click on design all, or we can go for design one by one. Here we have used flat plate slab and beam only used in the landing level. So first we can go for those beams. Click on this. We can go for grouping, automatic grouping, group all similar axes, group beam axis vertically, or group beam axis within the floor. Click on this. Then we can go for beam design base mode. Select new steel when previous bars are insufficient. Click on this, calculate, close. Now design done. Top bar 4, diameter 25, bottom 3, diameter 18. We can change this one if we want. This one 6 and this side 20. Then see the result. It is okay. Here the tie bar design. Click on OK. You can see the diagram also for different load cases and load combinations. Exit. Now close this one. Now we can go for column designs. Go for interactive design or column design base mode. Check still. Select new still when previous still bars are insufficient. Calculate. After finishing, close this one. We can see the result. We can see the diagram. This one envelope. Close. Steel bar diameter 20. Link pattern. From here we can choose link pattern, shear design, slenderness. It has been provided no text. Rebar diameter text. We can click on this. Column PMM interaction ratio. From here we can print report also. Close this one. We will check all the columns passed or not. Click on this. Reset bar. Then you can choose 20. Click on update. Click on OK. Now it is passed. Same way, this one, reset bar 20, 20, 20. Update. Click on OK. Done. 2C30 story 2. We can check this one. We can reset bars. Update. Now it is passing. We can copy bars in the same column. Select this one, then shift up to story 40. Same column C30 from story level 4 to 30. Story level 2 we have designed and we have copied bars. Now we will paste bars. Now we can see this 20mm die bar. Click on OK. Now this is design status is OK. Rebars will be pasted only. To update design we have to click on the cells, then click on OK. It will update the result with design status. In this way we can optimize our design. Now we can check shear walls. For shear wall there will be W. For columns there will be C. W5, 2, 4, 6. This is a small segment. We can see the image diagram. Click on OK. It's failed. Go for shear design. We can click on calculate. Now click on OK. It is passing now. Same way we can go for shear design, calculate, click on OK. It will pass accordingly. In this way we can optimize our wall design also. So after optimization of all the columns and shear walls, we can go for the reinforcement view. I will close this one. We can click on this, click on 3D rebar model, or we can go from view 3D rebar model. The view like this, then we will click on column rebars to see the column rebar. This is the rebars generated for columns. We can see rebar for walls also. This is shear wall rebars. In the next tutorial, we will see how to design flat slab in ProtaStructure 2021. After that, we will go for foundation design, then we will go for detailing. So keep watching the course on ProtaStructure 2021 and other important tutorials also in the channel. If you have not subscribed yet, please subscribe the channel. If you like the tutorial, press like button and share with your friends and colleagues.
Press the bell icon on the YouTube app and never miss another update.